Alright, so Alice and Bruce proofread a document that contains an error. The chance of Alice detecting the error is 0.60, and the chance that Bruce detects it is 0.5. Assume the events Alice finding the error and Bruce finding it are independent. We want to find the probability that both of them find the error. So since they're using the word both here, they're talking about an and probability. Yeah, so the probability of Alice finding it and Bruce finding it. The formula for A and B would be the probability of A times the probability of B given A. And so that's going to be probability of Alice finding it, 0.6, times the probability that Bruce finds it, given that Alice finds it. But A and B are independent events. And so when that happens, we know that the probability of B given A will actually just equal the probability of B, so it doesn't matter whether A happens or not. Yeah, when it comes to Bruce finding it, so that's going to be 0.5, and that comes out to 0.3. Okay, now that's going to be our answer for this first one. Now the probability that the error is found by at least one of them. So a Venn diagram can help to explain this. Alice finding the error could be the left bubble here. Bruce finding it can be the right bubble. So I'll call this A, and then B. A stands for Alice, and B stands for Bruce. Now we know the probability of Alice finding it, 0.6. Probability of Bruce finding it, 0.5. Clearly there's some overlapping region because adding them two together would be more than one, so there is a chance that both of them would find it, and we calculated that actually. It was 0.3, so there must be 0.3 in the middle. We want the probability that neither finds it and the probability that at least one of them finds it. So I'll start with the neither. So if we want the neither region, we want the region that is out here. We don't want Bruce to find it, and we don't want Alice to find it. So we need the complement of the bubbled region. We need the yellow region here. One option is to say that you're going to find the probability of not A and not B. That's what we need. So when we found the probability before, we had used two blanks where we would multiply two probabilities. We can do that again. What goes in the blanks? So what goes in the blanks would be, the first one's the chance of Alice not finding it. So for that you're going to want to do 1 minus 0.6. So her chance of not finding it is 0.4. And then over here for Bruce, his chance of not finding it is 1 minus 0.5. So that would be 0.5. So this is Alice not finding the error, and this is Bruce not finding it. And remember, they are independent, so it doesn't matter whether Alice finds it or not when it comes to Bruce not finding it. So let's see what that gives us. It gives us 0.2. Alright, so that means that the yellow region here has a probability of 0.2. That's going to go here. Then you want to find the probability that at least one of them finds it. So what they are talking about there is the probability of A or B, where either Alice can find it, or Bruce could find it, or even both could find it. The white region now. And so that can be found by the complement idea, where you have probability of A or B will equal 1 minus the probability of not A and not B. Because we know probability of not A and not B now. So it's going to be 1 minus 0.2, which is going to be 0.8. Another way of finding it would have been to use the OR formula, which would have been the probability of A plus the probability of B minus the probability of A and B. We certainly have all those things. You do 0.6 plus 0.5 minus 0.3. That would also get us to 0.8.